Hey, geometry. So today we're going to start chapter 7 with ratios and proportions. So section 7.1. Basically, I'm just going to do this with a bunch of example problems, and then you can practice with that and see how you're doing. So ratios and proportions. First example here: nutrition. 1 ounce of cheddar cheese contains 9 grams of fat. 6 grams of fat are saturated fats. Find the ratio of saturated fats to total fat in an ounce of cheese. So ratios, a lot of times we can write them a couple of different ways, but one of the most common ways to write it is with a colon. So find the ratio of saturated fats. We have 6 grams of saturated fat, and that ratio goes with per 9 grams of total fat. So that is a saturated to total ratio, which you can actually reduce this. So it's similar to a fraction. In fact, we'll write it as a fraction, but that can be reduced. We can divide both of those by 3. So this can actually become a 2 to 3 ratio. For every 3 grams of total, there are 2 grams of saturated fat. And so likewise, you can write this as 6/9, which you can reduce to 2/3. And that's a couple of different ways of writing that ratio. So those can be used in a bunch of different ways. The ratio of goats to sheep at a university research farm is 4:7. So for every 7 sheep, there are 4 goats. The number of sheep at the farm is 28. What is the number of goats? So while we've got that ratio, it might be nice to write that as a fraction, 4/7. And that's actually, I generally prefer the fraction, by the way, over the colon version of writing that ratio. So 4, and this is goats. We're doing goats per sheep. So there are 4 goats per every sheep. If we're going to match that ratio, the number of sheep on the farm is 28. And so we want to know what this number would be. And that ratio should be the same. That fraction should be the same. And so we want to know, what is this? And so we'll call that like X, or you could call it G if you wanted to, for the number of goats. And so then to solve this, we can do multiply by 28 on both sides to solve for X. A lot of times it's easier just to think of this as cross multiplying, just to get the fractions gone. So I'm just going to do that. It's cross multiply. So we end up with 4 times 28, which is 112. And then 7 times X. So we're kind of cross multiplying things here. 7X. The downside of doing it this way is that you get an additional step. I could have just multiplied both sides by 28 and had a fraction times 28. But the upside here is that I get rid of fractions pretty quickly. And so we can just divide then both sides by 7. And 112 divided by 7, you get X is 16. And so that means there are 16 goats. All right, the next one, quality control. A worker at an automobile assembly plant checks new cars for defects. Of the first 280 cars he checks, 4 will have defects. So we probably want to do this in this ratio of defects per car. So we had 4 defects per 280 cars. And you could write this. You don't have to write these words in there. You could leave that out. So I have 4 defects per 280 cars. Well, I want to make that if 10,500 cars will be checked this month, and predict the total number of cars that will have defects. And we're expecting that same rate or ratio. And so we're expecting whatever, we don't know, question mark, per 10,500. And again, this is defects per car. Per car checked. So we can then do the similar thing, cross multiply, and so we're going to get 280x is 4 times 10,500 is 42,000. And then if we divide both sides by 280, and we could have reduced this fraction, by the way. I'm sorry, we're out of focus here. Give me a second. There we go. We could have reduced that fraction 4 out of 280. We could have simplified that, but it's not necessary. It makes the numbers a little smaller. So an option you could go through, we could reduce that fraction. Anyways, here, once we cancel that off, we're getting X is, and this one works out to be 150. And that's defects. and that's like predicted or expect. All right, so then just some basic ones that have already been set up, just practicing solving these. Again, cross multiplying is always an option. You could also just, in this case, multiply both sides by 12. So let me show you that. I'll do more cross multiplying, but you could just do times 12 on both sides, times 12 over here. And so we get x equals, and it's like 12 times 5 over 8. And you could just punch that on into your calculator, and you get 7.5. But likewise, you could have cross multiplied. So I'll do something here. Instead of multiplying by 1.12, I'll cross multiply. So we'll get 5x equals 1 times 1.12, which is 1.12. And then we can just divide by 5. And we get x is, this one works out to be 0.224. This one, cross multiplication seems like it's not going to work. Well, we can think of that 43 as 43 over 1. That we can, if we want to write that as a fraction. So then we can cross multiply. We get 6x is equal to 27 times 43, which works out to be, let me just punch this in. That works out to be 1,161. So we get 6x equals 1,161. We divide by 6. And that one's not going to divide quite so nicely, so we get 193.5. Remember, you can always check answers, always a good strategy. So in this case, we could do 6 times 193.5, divide that by 27, so divide by 27, and 43 works out. Sometimes you may have to actually type in the fraction on the other side, or hit math frac. Here we got a little, this x plus 2 involved here. So we could do this a couple of ways. I'll do it one way with cross multiplication, one without. So we could do both sides times 3. So I'm just going to do times 3 on that side times 3. And so that'll cancel our 3's. We're going to be left with x plus 2 is equal to 8 times 3 over 9, right, which is 24 over 9. So x plus 2 is equal to 24 over 9, which we then can do minus 2 to both sides. So x is equal to 24 over 9 minus 2, which of course we could turn that 2 into, we want that over 9. If we want to subtract the fraction, do this all in our head, that would be 18 ninths would be 2. And so we'd be subtracting 18 from there, and so we get 6 ninths. So it's 6 ninths, which reduces to 2/3 for that one. There are other ways that we could approach that, and I'll do this one this way. So we could do cross multiplication as well. So I could do 3x minus 5. Ultimately, that whole thing is being multiplied by 7. I'm going to write it out there for distributive property's sake. And then 4 times negative 5. So 4 times negative 5. We'll distribute, and so we get 21x minus 35 equals negative 20. We'll add a 35 to both sides. We get 21x equals 15. Divide by 21, x equals 15 over 21. That fraction will reduce. We can divide the top and bottom by 3. And so that ends up being 5/7. Remember, you could also type this in, 15 over 21. Get that decimal. Prefer, if the problem doesn't originally start with decimals, not to end up with decimals. Usually if the problem starts with fractions, you want to end in fractions. If the problem starts with decimals, it's fine to end with decimals. So like, that's generally preferred. You could do the decimal, but especially this one, that's not nice. So nice to get that back into math and then fraction. And oh, I did that wrong. Math. Sorry, I just right there. And I need to do this one. Let's try that one more time. Grab this number, math, frac. And that'll, oh, well, look at you, not doing it. 15 over 21. And if we do it this time, it should work. Yeah, I don't know why that didn't work. That'll work. Yeah, I guess it just copies the 10th decimal place. So you want to do it with answer because it'll do the whole answer instead of just those 10 decimal places, I'm guessing. So you can get that 5/7 that way. All right, and then finally cross multiplying here. So we get 2 times x minus 2 for that cross, and then 4 times x plus 4. And so distribute, 2x minus 4, and then 4x plus 16, subtract a 2x from both sides, subtract a 16 from both sides, so that's gone, and so we're left with, this was minus 4, so this is negative 20 equals 2x, and so divide by 2, x is negative 10 for that one.